Hello and welcome back to my channel. Students, as you all know, we are doing a problem series, and in this problem series we have already covered a journey of 17 problems, and the problems encompass various topics like resonating structures, carbocations, carbanions, acidity, basicity, aromatic behavior, etc. Now let us try to see what is there for us in question number 18. If you see the question number 18 on your screen, as you can see, the compound carries two carboxylic group and the hydrogens are labeled as A and B. You have to tell the acidity of these hydrogens, which is more acidic, which is less acidic. Now, as you can understand the procedure I have been telling all these videos, you have to take the hydrogen out one by one as H plus. As you do so, there will be a resultant conjugate base. The atom from where the hydrogen is attached after removal of hydrogen as H plus will get a minus charge. So basically an anion will be the outcome of release of H plus. So you will create those anions one by one and will see the stability of those anions. The one which makes a better stable anion conjugate base will be more acidic in character in comparison to other. So let us straight away keep taking out the hydrogens one by one. So first I am going to take away the hydrogen number A. As you can see on your screen that I have taken the hydrogen number A out. As I took that hydrogen away, a minus charge came on the oxygen and you are looking at a carboxylate group right there. Now, as you all know that this negative charge that has came to this oxygen, you have to take care of that minus charge. And once I say you have to take care, you have to see the possibility of delocalization of this minus charge. Okay, so what are the possible ways how you can delocalize this minus charge so that this anion becomes stable and you can then comment on its acidity? Now, as you can see, you have this type of structure associated with the carboxylate group. Now, what I have tried to emphasize in this resonating structure is very important. Look, this double bond, you can polarize it for the sake of the convenience of this carboxylate. What I mean to say is, if you polarize this pi bond so that this particular carbon gets a plus charge and therefore the other carbon going to get the minus charge, then I am helping this carboxylate group to get satisfied. Why? Because as you do so, as I have done, this plus charge which comes on this carbon, you can understand from its minus I effect, strong minus I effect. As you can understand, plus charge has got great affinity for electron. It is going to pull away the electrons and therefore this minus charge sees someone delocalizing this charge and will be happier. Now, if you try to make the carboxylate group satisfied, stabilized by polarizing this pi bond, then a minus charge is also coming at this carbon. That also should be taken care of. Now, what is the role of this minus charge? You can now see that there is a ring, and this is a ring which is cyclic in nature, and once you see that all the atoms are sp2 hybridized and there is a cyclic conjugation. How? You can see minus, single, double, and once you do that, you include this carbon, and in this double bond both the carbons are included. So it's a cyclic portion of this species which is flat, and there is a presence of cyclic conjugation as you have seen. Now this cyclic conjugation is involving certain number of electrons. Let us first count the number of electrons involved. So you can easily see that 2 electrons from here and 2 electrons from here. All together in the delocalization you will have 4 pi electrons. And as now you understand, in the cyclic conjugation there is a possibility that that ring may be aromatic, it may be anti-aromatic. Okay, other possibilities also there. Since because of cyclic conjugation 2 possibilities arises, you know that for anti-aromatic, and as I have already told in several videos, in case of anti-aromatic, the number of electrons that should involve are 4n pi electrons, where n can be not 0, it can be 1, 2 and so on. So as you put n is equal to 1 students, you get the number as 4 pi. So it reveals a very drastic thing to you, that if you try to stabilize, satisfy this carboxylate by polarizing this pi bond, by bringing a plus charge in the nearest neighborhood, then the problem, a huge problem arises with this ring, because this ring is now becoming anti-aromatic in character. And as you understand, bringing anti-aromaticity is not good for the health of the species. Although you did something good for that anion portion, the carboxylate, but you have to give a huge price for that. The price is enormously high in comparison to the benefit you are getting out of that plus charge. So altogether, it seems like is not a good option, is not a good one to release the proton. Okay, now let us try to see what happens if we try to remove the hydrogen number B. So as you can see in this next slide, now I have removed the hydrogen number B, and now again a carboxylate group is created with a minus charge, and as the minus charge comes, it's now is your curiosity that whether this minus charge is going to get stabilized or not. And the way you did in the previous slide, if you try to see that if I polarize this pi bond, look at the way I am doing. If you polarize it as you did in the previous case, you understand there is a double bond, there is this double bond, and now you can see a conjugation double, single, double. And because double, single, double is there, you understand you have to shift the pi bond, and in shifting you have to consider that this is a group which is electron withdrawing in nature. COOH is electron withdrawing in nature, and COO minus is electron donating in nature. This is electron withdrawing in nature, and this is electron donating in nature. Now what happens if you try to shift these pi electron? The natural choice will be towards the electron seeking group, electron withdrawing group. So if you have thought all these points, then the way you are going to shift the electrons will be like this. You are going to shift these electrons on this carbon, and simultaneously it will shift to this place, and this carbon will lose electron and therefore will get a positive charge. As you can see, this carbon has got a positive charge, a new pi bond has been created, and the older pi bond is now is on the carbon as a lone pair and a negative formal charge. And now you understand something very advantageous has happened. What are the advantages of doing this resonance? There are two very important advantages. First of all, you can easily see this minus charge can now be taken care by an electron withdrawing C double bond O group. How? Minus, single, double. So once you see that there is a possibility of conjugation, there is a conjugation and a possibility of resonance, and now these electron goes like this and the pi shifts on more powerful oxygen which could hold the negative charge in an easier manner in comparison to carbon. So you draw this structure, and as you draw this structure, you feel relieved that now the oxygen is bearing the minus charge, is a good structure. And on the other hand, the second advantage is a huge one. You have got now a ring that has all the carbon in the same plane, is a planar ring, and there is a cyclic conjugation. How? Let us try to see. If you try to see that cyclic conjugation, plus, single and double. So in this conjugation you have included all the 3 carbons, and you understand the number of electrons which are involved are 2 pi electron, just 2 pi electron, because plus is not going to contribute any electron. So 2 pi electrons are now moving inside this ring in a cyclic manner. The cyclic conjugation is there, and you understand the Huckel's rule is followed. And what is the Huckel's rule? I have told you several times. It is a rule which decides whether the species has aromatic character or not. If you have the number of electrons in the ring in the cyclic conjugation following 4n plus 2 formula, where n can now be 0 or 1 or 2 etc., then it is called as aromatic. As you put n is equal to 0, student, then you will find that it will give the result 2 pi electrons are able to get this ring aromatic in character. You find, yes, this ring is aromatic. So not just one. By doing this conjugation, doing this resonance, you have got 2 advantages. The minus was taken care by C double bond O, and the plus gave a very healthy thing to this species, that is aromatic character. Now, what is all these at the end of day going to give this acid the strength? What strength this acid is going to get from all these things? So you should understand, and a very important thing, as you get this plus charge here, you understand this plus charge is now going to pull these electron, and as you are going to pull these electron through minus I effect, this minus charge from the carboxylate group is now getting delocalized. You are spreading the charge, dispersing the charge, and dispersal of charge is a very good thing for the stability of the charged species. And that is how you come to a conclusion that removal of the hydrogen number A, gives you a better alternative, an anion with the nearest carbon bearing the positive charge, and the system is stable altogether because of all the things I have shown, that minus is taken care of. This ring which gets the plus charge is aromatic in character. That is how we come to conclusion that, what is the final conclusion? Our final conclusion is this hydrogen is more acidic in character in comparison to the above. So the acidity order is B greater than A. So altogether, if you take all the concepts on your fingertips, I first took out the hydrogen, then created the anion, then thought about the stability of anion, then thought about some resonance possibility, and through resonance possibility, if I find that it is giving some bad character to that species, like the removal of hydrogen number A generated an anti-aromatic ring out there, so it was not a good option. Okay, it was not a better option. So I then went to hydrogen number B, and again I tried to do the polarization of the pi bond, doing the resonance. Then I found that, okay, this is a better option. The polarization resulted in minus charge and a plus charge. Minus was taken care by the C double bond O of the COOHA. On the other hand, the plus came inside the three-membered ring, giving it an aromatic character, and simultaneously that plus charge was pulling the minus charge from the COO minus, which is created by removal of hydrogen number B. So the removal of hydrogen number B we found is a better option in comparison to A. So I hope you all must have given a proper notice to all of very crucial important points, and I hope you are understanding all the videos in the same pattern, and will bring more questions like this. Till then, keep watching my videos, keep a good look on all the points which I am emphasizing, and if you have any doubt at any point, you can ask me in the comment section. Till then, take a good care of your health and happiness. Thank you very much.